In Solidity, gas is not much of a concern for contract developers. If the user provides too little gas, everything will be reverted as if nothing had happened, but the gas will not be returned. If they provide enough, the actual costs will be automatically calculated and deducted from their balances. In Ton, the situation is different. If a group of contracts exchanges messages, then control and calculation must be carried out in each message. Ton cannot automatically calculate the gas. The complete execution of the transaction will, with all its consequences, can take a long time, and by the end, the user may not have enough Ton coins in their wallet. The carry value principle is used here. We can use our message flow diagram to estimate the cost of each handler in each of the scenarios and insert a check for the sufficiency of message value. Find entry points in the message flow, estimate the cost of each handler, check in entry point that the message value is enough, and you can't demand enough with a margin everywhere, say 1 ton. The gas is divided among the consequences. Let's say your contract sends 3 messages. Then you can only send 1/3 of ton to each. This means that they should demand less. It's important to calculate the gas requirements of your whole contract carefully. Things get more complicated if, during development, your code starts sending more messages. Gas requirements need to be rechecked and updated. If excess gas is not returned to the sender, the funds will accumulate in your contracts over time. In principle, nothing terrible. This is just a suboptimal practice. You can add a function for raking out excess, but popular contracts like Ton Jeton still return to the sender with the message excesses. Ton has a useful mechanism. Send mode carry all remaining message value. When using this mode and send row message, the rest of the gas will be forwarded further with the message to the new recipient. It is convenient if the message flow is linear. Each message handler sends only one message. But there are cases when it is not recommended to use this mechanism. First, storage fee is deducted from the balance of the contract and not from the incoming gas. So if there are no other non-linear handlers in your contract, then over time storage fee can eat up the entire balance because everything that comes in has to go out. The second, if your contract emits events, that is, sends a message to an external address, the cost of this action is deducted from the balance of the contract and not from message value. And the third case, if your contract attaches value when sending messages or uses send mode pay fee separately. These actions deduct from the balance of the contract, which means that returning unused is working at a loss. Let's take a look at the example of code snippet from the Ton Jeton. This is the common way to keep the contract balance stable. We can see that first we determine what we need to keep at the contract as a storage fee. Then we subtract these values from the incoming message value. And then we can send the excesses manually calculated to the sender address. Remember that if the value of the contract balance runs out, the transaction will be partially executed, and that cannot be allowed. Let's summarize what we have. Ton requires deliberate efforts from developers to manage the gas, calculate the spending, and checking if enough provided. Gas cost can rise over time if unbounded data structure used. Ton recommends returning the excesses to the sender. It is also on developer. And if run out of gas, the transaction will be partially executed, and that can be a critical issue.